Today in geometry, we're going to work on lesson 2.3, which is two-dimensional figures. Essentially, what we're looking at here are some of our basic two-dimensional shapes, triangles, rectangles, squares, and circles. And we're going to find perimeter or circumference and area for these and look at them in some different situations. Okay, so first off, we're going to look at triangles. And before I get into the specifics of this, let's talk about what we're going to work on today, which is perimeter, area, and then a little later, actually tomorrow, we're going to do more circumference, which is for circles. So perimeter by definition is the length of the path that encompasses or surrounds a two-dimensional shape. It can also be thought of as the length of the outline of the shape. And essentially what we're going to do is take the sum of the side lengths to get the perimeter of a shape. Okay, now area is defined as a space that's occupied by a flat, which is a two-dimensional shape. Technically, it's the number of square units that cover the surface of that closed figure. Okay, so today we're going to begin with triangle. All right, and I gave you two different triangles to look at here for starters. This is an acute triangle, and in an acute triangle, the height of that triangle will be on its interior. The height of the triangle has to be a line that goes from the top of the triangle to the base of the triangle and does so at a right angle. It's got to be perpendicular to the base. So in the triangle here, the base has got to be B, where H is going to be the height. Over here in my right triangle, okay, you can see that this side is perpendicular to this side. So that actually makes this side also the height, and this side's the base, because we said the height has to go from the top of the triangle to the base and do it on a 90. Well, in this case, this side does that. The other thing you'll notice are the side lengths are just labeled with B, C, and D. Okay, and that's just represents a number. Okay, so looking over here, if you found the perimeter, you would not include H because it's not an outside side length. Over here, your side length and your height are the same thing, so they get counted in each. Okay, to find the perimeter of these triangles, we would take the three outside side lengths, which is the perimeter of it, or the the outline of the shape, so to speak. We just add those together. To find the area of any triangle, it's 1/2 times the base times the height. And again, the base has to be the side of the triangle that the height is perpendicular to. Okay. You can write it like this if you want. B times H divided by 2. It does the same thing. Okay. All right, here's a couple applications of finding the area of a triangle. So here's a triangle. Again, it's an acute triangle. The height is right here on the interior. So they're giving you some extra dimensions. They just want to be sure that you can pick out the right ones here. All right, so if we're going to find the area of this triangle, we're going to do 1/2 base times height. The base has to be the 20 because the height is 5 and it's perpendicular or a right angle to the 20. So we're going to go 1/2 base of 20, height of 5, and that's 50 yards squared. Area, guys, is always units squared because you are actually finding how many square yards, 1 yard by 1 yard square, how many fit inside of there. So we have to be descriptive with our answer here. Now over here, we're in the coordinate plane and we're asked to find the area of this shape. Well, this is a right triangle, right? They give you the right angle here, and you can see this is a vertical line and this is horizontal. They're going to make a right angle. So we find the area by going 1/2 base times height. Now, they don't tell us any of the dimensions, but we can go in there and count. The base is 2 units. The height is 7 units. There's no need to get fancy. We can just count because this is a horizontal. This is a vertical line. So we just count it out. Okay. So I know my base is 2. My height is 7. 1/2, 2 times 7. That's going to be 7. And we just write units squared. We weren't given a dimension, but we're talking about units here. Whatever they would be squared. Okay. Now throw squares and rectangles in the mix here. So here's our square. You know, a square has all sides that are the exact same length and all angles are 90s. And a rectangle has sides that opposite sides that are the same length, but not all 4 are. So this W and this side are both W. This side is L. This side is L for a length. Okay. A square is a rectangle, but a rectangle isn't a square. We'll learn that later. Okay, but to find area and perimeter here, so the perimeter of a square, since there's 4 sides and they all have a length of S, we just say it's 4S. The area, you can say length times width, but it's S times S. And whenever you multiply a number by itself, it's like squaring it. So we just say the area of a square is side length squared, side times side. Over here, the perimeter, we usually write 2L plus 2W. There's 4 sides, 2 of them are L's and 2 of them are W's. So 2 L's, 2 W's. Give you the distance all the way around. Or you could write it like this if you want. 2 times the quantity of L plus W. That will do the same. And then area here is length times width. So length times width will tell us how many square units fit inside there. Okay, I'm sure you guys already know this. We're just kind of hitting it again though. All right, find the perimeter and area for each rectangle. This is pretty straightforward stuff. So the perimeter is 2L plus 2W, 2 times 11 times 2 times 6. And by the way, it really doesn't matter which one you want to call length and which one you want to call width. You're going to get the same result here. Okay, so it's 22 plus 12 is 34 yards. Now these are just straight units. These are linear distance. Okay, so straight units, no squaring of the unit here. And over here, it's a might bit tougher because they give us some fractions, actually some mixed numbers, but it's the same process. Oops, forgot to do my area over here. Area is length times width for the rectangle. 6 times 11, 66 yards squared. Again, now it's an area, so we got to square our units. Okay, I was ahead of myself. Now let's take a look over here. If we're going to find perimeter, we still do it the same way. 2 times L plus 2 times W. So the perimeter is going to be 2 times 4 4/9 plus 2 times 2 1/5. Okay, there's some algebra work here, or it's just some basic computation we have to do. But 2 times 4 4/9 will be 8 8/9. 2 times 2 1/5 is 4 2/5. Now we have to add these together. Remember, to add fractions, you have to get common denominators. So this 8/9 became 40 45ths. This 2/5 became 18 45ths. Now we can add things together and simplify. We wind up with 13 and 13 45ths feet for perimeter. Area, length times width. So it's 4.4 and 4/9 times 2 1/5. And that's going to be 9 7/8 feet squared. Okay, so pretty straightforward stuff there. A little bit more detail here. You have to write. This is more algebra based. You got to write our own formula, so to speak, and then answer the question. It says the length of a rectangle is 5 centimeters longer than its width. If the perimeter of that rectangle is 42, find its area. Okay, so the length of the rectangle is 5 centimeters longer than the width. What this tells us is we're basing the length of the rectangle on the width. So I want the width to be my variable x. Now, if the length is 5 more than the width, then the length is x plus 5. Okay, so I got my two unknowns described, and now it says the perimeter of this rectangle is 42. Well, we know we find perimeter by taking 2 times the length plus 2 times the width. Here's my length, x plus 5. Here's my width, x. I'm going to plug them in. So 42, which is, they tell us a perimeter, 2 times the length, which I put quantity of, because I got to double each of these, x plus 5, plus 2 times the width, which is x. Distribute our 2 through this parenthesis. Combine these two like terms. Subtract 10, divide by 4, and x is 8. Now, that's x, but that's not near the answer here, because they want us to find the area of this said rectangle. Well, what we now know is the width is 8 because the width was x, and the length is going to be 8 plus 5, which is 13. So now I know specifically what the width and length are. Now I find area. Area is length times width, 8 times 13. The area is 104 centimeters squared, right? If my perimeter is given in centimeters, my area is in centimeters as well. So that's a nice little problem. Takes a little bit of algebra there, and you got to reason your way through it. Another application, let's say we're asked to find the area and perimeter of a rectangle given these vertices. Okay, well, what I would do is make a quick graph. Okay, if you got graph paper, use it. So plot -1, 0, -1, -3, 4, -3 would be down here, and 4, 0 would be there. Okay, so plot your points. Okay, they're telling you it's a rectangle, but it's nice to see it. Now, if I kind of shade it in here and count, the width here is 3 units and the length is 5 units, and just count them. So it's 3 by 5. So the area, length times width, 15 units squared. The perimeter, 2L plus 2W, 16 units. pretty simple, but it's much easier if you just make a quick sketch of it so you can see it. Okay. Okay, it says the figure below shows a rectangular court. So this is like a basketball court, 94 feet, which I think is the length of a basketball court typically, by 78 feet. And they tell you it's a rectangle. Question A, find the perimeter and area of this court. Make sure to include correct units. All right, so area, length times width, it's a rectangle. 94 times 78 is 7,332 square feet. Perimeter, 2L plus 2W. 2 times 94 plus 2 times 78. That's 344 feet. Okay, so I got my area, I got my perimeter. Question B. The court is going to have wood floor. Which measure would be used in finding the amount of the wood floor needed? So we're going to need area or we're going to need perimeter. Well, when you put a wood floor down, you're covering this whole interior surface. So you are finding the area inside this shape, so it's definitely going to be area. So we're going to want to use this 7,332 feet squared to help us figure out how much wood floor to get. C here says we're going to put a strip of tape around the court. Which measure would we use in finding the amount of tape needed? So if I'm going to put a piece of tape around the court, I'm going to start, let's say here, and I'm going to go all the way around the court with tape. That's definitely perimeter. Okay, we're going to want to use the 344 feet for that one. Okay. A little different now. They're giving us the information a little different. The square has an area of 64 meters squared. What's the length of each side? Okay, so we're talking about the area of a square. So I use that formula, area equals side squared. Okay, now area they're telling us is 64. So 64 equals side squared. I'm sure many of you already know what the answer is, but I'm going to show you mathematically what we do, and you should remember this. We take the square root of both sides. The square root cancels a square. Take the square root of 64. We're going to take the principal square root, which is the positive one, and S is 8 meters. So if a square's got an area of 64, it's got a side length of 8. Okay, a square's got a perimeter of 144. What would each side length be? And again, we're talking about the perimeter of a square, so that's the formula I pull up. Perimeter equals 4 times the side length. Now, said perimeter is 144. So 144 equals 4S. Divide each side by 4, and each side has to be 36 centimeters for the square to have a perimeter of 144. Okay, just a different type of question. Now we get into some, some shaded region type questions, and you've done these in the past, I'm sure. It says a rectangular region is removed from another rectangular region to create the shaded region below. Find the area of the shaded region. So the big overarching concept here is we got to find the area of the large rectangle and take away the area of the small one. Okay, so we're going to take the area of the big triangle or rectangle, subtract the area of this white one on the inside, and what's left will be this part, the blue part. So how do you find the area of the big triangle? Length times width, rectangle, length times width, 8 times 12. And then we're going to subtract the area of the small one on the inside, 3 times 7, 96 minus 21, 75 square feet. So the blue part here, sometimes it's called like a picture frame. Okay, this blue part is going to be 75 feet squared. Okay, over here it says the entire rectangle below has an area of 48 inches squared. Find the area of the shaded triangle. Be sure to include correct units. So what we see here is the area of the triangle is exactly 1/2 of the area of the rectangle. Okay, so 1/2 of 48 is 24. So the area of this blue triangle and the area of the white triangle, if you want to look at it that way, they both have an area of 24 inches squared. All right, couple more examples. A rectangle is removed from the right triangle to create the shaded region. Find the area of the shaded region. Be sure to include correct units. Okay, so again, you look at the overall concept here, and it's to find the area of a triangle, this big right triangle, and subtract out this rectangle. Take that piece out. Okay, as you look at this, remember that the opposite sides in a rectangle are the same length. So if this is 3 yards, this dashed line is 3 yards. And what that means then is this total height here for the triangle is 8 yards, 4 plus 3 plus 1. So the triangle has a height of 8 and a base of 10. And you know the rectangle is 2 by 3. Okay, so the triangle we find by going 1/2 base times height minus the area of the rectangle, 3 times 2. It's going to be 40 minus 6, which is 34 yards squared. Okay. Over here, it's a rectangle, and we're going to cut out this triangle right here. We're going to take this triangle out of the rectangle. All right. So the overarching idea is to find the area of the rectangle, subtract out the triangle. Now we got to deal with these lines because we got to figure out what they are. Okay. And the way we're going to do it is, if this is 7 yards, then this has to be 7 yards. If that's 4 of it, then 3 of it's right here is the dash part. If this side is 8, this side's got to be 8. And this much is 3, so that's got to be 5. Okay, so what that does is give us the dashed lines, which are also the base and the height of our triangle. Okay, so we got to find the area of the rectangle, subtract the area of the triangle. Rectangle is 7 by 8. That's its area. Triangle's 1/2, 3 times 5. We're going to get 56 minus 7.5, which is 48.5 yards squared. The area is always yards squared. Okay, so it's just a variety of different questions on the basic, two-dimensional figures that we deal with: triangles, rectangles, and squares. Applications in different ways. Just write down what you're doing, guys. You always gotta show work. Whatever your thought process is, put it down on paper. Okay, I'll talk to you later.